Let's start lab 3. Open file cars04. Right click here, save link as. Then you can see that I have already downloaded cars04 file. If you haven't done that, then click on save. Then if you already have downloaded the file, then just cancel it. So after we have done that, go to Excel, click on file, click on open, browse. Since I have downloaded the file in downloads folder, click on download and click on text files. Since there are a lot of files in my download folder, so I just want to be specific to get text files. Okay. Then we need cars04 file. Open it. Then delimited is what we choose. Click on next and finish it. Looks good. You can see that we need to produce a chart with x-axis to be the length and y-axis to be the CTMPG. So here let us find the length of the car. This is it, and CTMPG is this one. Okay. So select CTMPG, press on Control, hold on Control button, and click on this column of length. So these two are selected. Control C, then come up with a new worksheet and Control V. So we get so we have pasted the selected data. But what we have been asked is we need length to be in x-axis. So for that I want to switch between these two. So here's a good trick, that if you just select this column, select the first column and hover on top of column, the selected column, right click, then press insert, then one column will be added. So now you can just select this column C, okay, Control X and Control V. So everything is shifted. So I did Control X. Control X means cut, okay, and Control V will paste. So that looks good. Now let us select both of these two columns and click on insert, go to scatter plot and click on scatter. So this looks good. I would like to remove this empty space, so that should be somewhere. Okay, let's go for access and click on this little arrow and click on more options, then you'll get this kind of thing. So click on bar, and minimum bound for x-axis would be, let's go for 130. I think that should be good. Okay, 130 looks good. And for the y-axis we might want to change this to 10, the minimum bound to be 10. Click enter. So that looks good. Now let me just increase the size of this figure. Okay, you may or may not want to do that, that's up to you. And since okay, so let me click on axis title. I want axis title here. So this one is length of cars. Okay, click on enter. That sounds good. And this one, CTMPG. Click on enter. So we get this one. So now another thing is that we need to go for positive or negative trend. So for that we would just click on plus and go to the trend line. Click on this small arrow button, go to more options, then click on this graph. Then you'll see okay, I just want an equation, so click on display equation on chart. So that looks good. So here you can clearly see that y equals to negative 0.249 is the slope, and it is negative, so you can see negative trend here also. And also if you want to do some kind of cosmetics, go to this bucket and go to border, then go for, and don't forget to click on this trend line. Okay, then click on color, that's black, and click on dash type, that's bold, so you get the straight line in this. Change the title. So length of cars versus CTMPG. Now we have already known this is negative trend, so we are good. Is this trend expected? Yes, it is expected, since as the length of car increases, then the weight of the car also increases. So does this trend means city MPG increases with the car length? No, since we have negative trend, so this is not true. What does its dot represent? Its dot represents a car, and it's the combination of length and city MPG. Tutorial: upload data smoking and open data in Excel by following from lecture 2 and 4. If you go to lecture 6, you can just go to statistical method and go to video lecture 6, then click on task 2. Alright, so lab 3 task 2. Use the mileage data and create a chart XY coordinate being car mileage in thousands and car gas mileage in MPG. Okay. So mileage data, right click on save link as. Here you can see that I have already downloaded mileage data file, so that's it. Now let us go to file and open, browse. You can see the mileage file, click that, okay, and go for text files. Okay. If you have a lot of files in your download folder, just click on this drop down menu and click on text files. Okay, click on mileage and open. So this is delimited, choose that and go for next and tab. Okay, mileage in thousand and miles gallon. Okay, so that's good. Finish it. So we get this kind of data, and here if you hover in between two columns, then you will see this kind of symbol. Double click, you can see mileage in thousands. Here also the same. Now click on plus sign, then on the trend line. Okay, so our X and Y coordinates should be car mileage in thousands and car mileage in MPGs. So that would be, select these two columns, go for insert, scatter plot, scatter. Now what I can do is I can just click on the x-axis part. Now let me get rid of this empty space so that the data will be a little bit nicer. Click on plus, go for axis and click on this small arrow on the right, more options. Then for x-axis, click on this bar. Minimum might be 15. Let's go for 15. I think this should hold. Yeah, it looks good. And for y-axis, click on any number in the y-axis, and here click on graph. Then you can see minimum and maximum values. So for this, minimum might be 39. Let me go for 39. Then it looks much nicer. And I would go for axis titles. Okay, so this one is x-axis, so mileage in thousands. Okay, 1000, that looks good. And for y-axis, miles per gallons. MPG, let's just write it in this way. So that looks good. Okay, we need equation also, and trend line. So go for trend line, click on this small arrow, more options, click on this bar graph and click on display equation on chart. Click this, looks good. And I would like to take this equation on top of the table, on top of the chart, so let it be here. So that looks good. Now click on this line. Once it is selected, click the button, this button, the bucket button, and go for, I want to have black color for that line, so click on black and dash type to be solid line. Now here it says which kind of trend do you observe. Clearly it's a negative trend, since the slope is also negative, and you can just visualize that. That's negative. Is this trend expected? Is this trend expected? Yes, the trend is expected, since as the car gets more mile over the years, then the performance really starts to get lesser and lesser effective than when it was new. So this trend is expected. That's S. What is the slope of the line? Slope of the line is 0.833 negative. This one would be the correct. Given the data, what is the interpretation of the number 48.76? 48.76. 48.76. Okay, so here you can see that this number 48.76 is y-intercept in the context of this straight line, but it has nothing to do with the mileage of the car. Okay, since it does not affect anything. If the car has 0 mileage, then it will give us 48 miles per gallon. That's fine, looks plausible, but it doesn't have anything to do with this one. Okay, so this number is meaningless in this setting. If the equation was just simply an equation related to real numbers, then it might have some work with the data with that setting, but in this setting it is meaningless. So click on this one. Right. So we are good. Let's go for task number 3. Use the flyers customer data and create chart with X coordinates being flyers and that the manager distributed weekly, and Y coordinates being number of weekly restaurant customers. In addition, add the trend line and its equation. So let's download this flyers customers. Save link as flyers customers. Save it in the downloads folder. Let's go for Excel and go for File, Open, Browse, and let's find out flyers customers. Click on Open. Looks good. So go for Delimited. Click on Next. So flyers and customers, they have been nicely represented. So it looks good. So finish. Thus we get this kind of data. Here, once the manager, I want flyers to be in x-axis and customers to be in y-axis. Okay, looks good. Click on Insert, Chart, Scatter. Okay, so this looks very good. And click on plus. Go for the trend line. Click on this arrow, more options. Click on this bar graph and click on display equation chart. Looks very good. Let me put it up here. Okay, then click on this line. Once it has been selected, go for this background color. So color is black for me, and dash type is the solid line. So it looks good. Now it has a increasing trend, but the increase is very minimal. It's a very small increase in terms of what we see here. Which kinds of trend do you observe? It's a positive trend. Is this trend potentially good news regarding the increasing restaurant profit? Yeah, once the flyers has been distributed more, then the customer also, the turnout of the customer will also be more. So that's a good trend for the restaurant. Yes. Slope of the line 0.222297. Given the data, what is the interaction of the line of the number 315.48? 315.48 represents y-axis, y-intercept. But here we can see that if we so this is just y-intercept, and whenever x equals to 0, that means if the restaurant manager doesn't distribute any flyers, then there will be 315 customers. This number is meaningless in this setting. All right. Go for tutorial somewhere here. So this is task 3. After task 3 we have tutorial. You can also go for the videos, computation. That's fine. Open Tornado's data. Make sure that the screen is split and labeling months is correct. The data file should look like this. Okay, so let's download this data, Tornadoes. Right click, save link as, and click on save. I have saved this in my downloads folder. Go to Excel, click on File, Open, Browse, click on Downloads, click on Text Files, and here you can see flyers. We have already gone for flyers. Tornadoes is the one which we want. So click on Tornadoes, click on Open, and delimited is what we choose. Tornadoes, deaths, and deaths by year and month, 1952 to 44. Okay, so there is a lot of data. Click on next and finish it. Okay, so this is, so let us split the screen. Okay, so let's put it somewhere here, 16, the 16, and click on view, split, place it in this way so that we can see the top and bottom of our data. Next, in the cell below January, enter data, write down sum C49, C5 to C49. Click on copy. Okay, so I can simply write this as sum C5 to C49 and click on OK. So now once you have written down this array C45 to C49, then it automatically highlights it. Click on enter, then you get total sum of the tornadoes in January of all these years. So what we have done here is we have added all the cells from C5 to C49. Now we also want to do for all of these columns. So at the right end of the corner, right corner of the cell, then hover it around just like this, and after this plus sign appears, then left click and drag it horizontally until we get to the end of the data. So now you can see that everything is added up. Okay, so this was sum from C5 to C49, this one D5 to D49, this one O5 to O49, and so on. Starting with the newly created raw data, the sum of number of tornadoes for each month, the goal is to create a chart below. So to create a chart using this information that we got just now, so here as you can see that this chart is from January to December. So let's go for, let's select from January up to December, and then click on insert, click on this line chart, and click on this one, line with markers. Highlight the newly created row and choose the plot with connected dots. That's fine, we have already done that. Okay, so to change the levels of x-axis to January, February, March, April up to December. Okay, so what we do is we select the chart, right click, and after right click you go to select data, this one. Okay, select data, click it, then you can see this kind of dialog box. Then you can, now I would like you to go for this edit button, click it, and again click in this arrow. Okay, so here it says the select the range, so that's why we are trying to select the range at first. So click here, then now we need to select the range, then go for the values in the column, okay, sorry, the values in the row 4 from C to N, okay, from January to December, in this way. So that's it, and then click on this down arrow button here, okay, in this axis levels. So click on this arrow, then you can see how things are populated here, and click on OK. Thus we get an OK again, so that's good. So that's what this tutorial means. This way you can change the levels of axis. Now let's go for task number 4. Use tornadoes data and procedure described in the tutorial on tornadoes to create a chart where x-axis are months and y-axis contain average of tornadoes per month. Okay, now let's go for task number 4. It's a test. Use tornadoes data and procedure and the procedure described in tutorial on tornadoes to create a chart where x-axis are months and y-axis contain average number of tornadoes per month. And hint, to compute average type equals to average C5 up to C49. Okay, so let us try to come up with the chart where x-axis is months and y-axis is the average number of tornadoes per month. Since we want to find the average of each of the columns, okay, for each of these columns, then I would go for equals to average, and we just need the data for just 1 year, so we would just go for up to December. Okay, so click here and click left and go up to December. Now insert, click on insert and draw the graph. So go to this markers, line with markers, click here. Then we want so here let us just simply write average tornadoes by month. Click here, right click and go to select data. So after we have done that, so click on this edit, okay, and click on this up arrow pointing upwards. Then now you need to select all the data levels, okay, axis levels. So click on January and drag it up to December. So after we have done that, and here we can also reconfirm that we are selecting this from C4 up to N4. C4 is January and N4 is December. So then after that you click on this down arrow. So here you can see now January, February, March, April and up to December is there. So click on OK. Thus, and here also OK. So let's answer 13 and 14. Which 2 months have the highest and lowest averages respectively? Highest and lowest. So first we need to go for highest. Let's go for highest. The highest is this one. That's May and the value is 162.97. Highest is May and the lowest would be January, right? Since December is slightly more than January. So May and January. And then which month has the third lowest average? And what is the average? Third lowest average, first lowest, second lowest, and the third lowest is February and it is 20.68. so we round off it to 21. February 21. So February 20.7. That's fine since 0.68 means 7. February and 20.7. Good. Now use the tornadoes data and procedure described in the tutorial on tornadoes to create an additional row data containing standard deviation of tornadoes per each month. Hint, to compute in standard deviation you go for standard deviation C5 up to C49. Okay, so let us create another row of datas which is the row of standard deviation. So let us write standard deviation of each month, right? So then in this cell let us write down equals to STDEV, that's the formula for standard deviation, and let us go for C5. C5 is the first cell of January and semicolon C49 is the last cell. Okay, so looks good. So that's our okay. So this is our standard deviation. Okay, so the standard deviation for month of January is 11.07. Hover above the cell and whenever the plus sign appears, then click left and drag it all the way to the last cell. So that's fine. So we got a row of standard deviation. Which month has the lowest standard deviation? Now for this also let us go for let us try to draw the chart. Okay, so here let us create another chart. So that's average tornadoes by month. Now let us create standard deviation of tornadoes each month. Okay, so select the data, select one cell and click on left click and drag it up to December. Insert, go to line graph and this one, okay, line with markers. Standard deviation of tornadoes by month. Okay, click on the chart, click right, select data, click on this edit and click on this up arrow, and then axis level is January up to December. So that looks good. Click on this arrow, down arrow, and click on OK. So you can see January, February up to December, and click on OK again. So that looks good. Now tornadoes by month, right? Okay, so let us answer the question. Which month has the lowest standard deviation? So the lowest standard deviation is January. It is 11.07. And highest standard deviation would be this one, 75.16. Wow. Highest standard deviation is this one, which is June. Okay. Create the third row data containing the range of numbers for of tornadoes for each month. So we also again need to do the similar kind of thing that we have done for standard deviation. So this is range. So range is just the maximum or minimum. So here you can just type yeah, so let us just copy this, equals to max minus min. Copy and click it here, copy and paste. So equals to maximum of C5 up to C49 minus minimum of C5 up to C49. So this basically just finds the range of the data from ranging from the minimum up to maximum value. So click enter. Thus we have the range of in January is to be 52. So that's it. Thus we got the minimum and maximum minus minimum. Answers questions to 17 to 20. So here let us again go for draw the graph. So select all of these things. Oh, I just need to select up to December, right? Okay. So select up to December, just like the way that we have done previously. Insert and line graph. So go for this one, and in chart title we would like to write down. And here again the same thing, we want a month, right? Name of months here. So right click on the chart. Okay, right click on the chart, select data and click on this edit and click on this up arrow and then select the range. Okay, so click downward arrow. You can see now it's populated. So click on OK. Alright, so the highest range of tornado is this one, that's June, which is 371, and lowest range of the lowest range is either January or October. Okay, so that's January. So highest range is June and January. Oh, okay. Here it says which month have ranges below 75. Ranges below 75 means you can just go for, this is 100, right? 75 should be somewhere here. This is 81, we don't consider that. So January and October is the correct choice. Good. Which month has the highest sum of tornadoes? Need to create another row. Now let us create another row for that. So that was average, range, and highest and lowest. Okay, so this would be sum equals to sum C5 up to C49. Click on here. So this is sum. Then drag it. Then drag this all the way to get the sum of the tornadoes, right? And let us select up to December. Click insert. click on this graph. So click here. So the chart title would be sum of tornado by month. Right click, select data, click on edit, click on this up arrow and choose the level f-axis. Good. Click on this down arrow, click on OK, click on OK, then we are good. Sum of tornadoes by month. Okay, so sum of tornadoes. So let's try to see which is the greatest sum. So the greatest sum here is of May. Lowest sum is January, 595. December is 765. So January is the lowest and May is the highest. Highest sum of tornadoes, May. Lowest sum of tornadoes, January and December, of course. So those are the two, January and December. They have the lowest.